Now we're going to look at the empirical rule for data with a bell-shaped distribution. If I were to draw a bell curve, here in the middle is the mean. And if this is one standard deviation, we'll call it mu. This would be mu minus one standard deviation. And this would be mu plus one standard deviation. 68% of all my data is going to lie in here within one standard deviation. This is 68%. If I want to find two standard deviations, 95%, let's say this is 95%, and that would be two standard deviations. And then if I go to three standard deviations, this is three standard deviations. That means 99.7% of all our data is within three standard deviations. 68, 95, 99.7. And here's the nicer picture. These are more exact. So 34.13% lie to this side and 34.13 lie on this side. So if I add it together, it's 68.26. We're estimating it at 68%. That's within one standard deviation. Two standard deviations, we add on more, and that's about 95%. And three standard deviations goes all the way out here. Look how small what's left is. There's just a little tiny bit on both sides. Under this entire curve, we have 1. If I add up all the percentages, I have 100%. Probabilities always go from 0 to 1. That would be the same as 1 probability. Under this entire curve is 1. Since this is the middle right here, 50% lies to the left and 50% lies to the right, 0.5 and 0.5. If I want to find out what is more than 3 standard deviations away, it would be 100 minus 99.7, which is equal to 0.3%, which is equal to, that means that half of that, 0.3 over 2, is equal to 0.15. 0.15% is outside of 3 standard deviations, which is pretty close. We're just estimating. It's really 0.13. IQ scores have a bell-shaped distribution with a mean of 100. That means in the middle, we have 100 and a standard deviation of 15. Let's say this is one standard deviation. This would be 100 plus 15, which is 115. And on this side, we would have 100 minus 15, which is 85. 68% of all people, if you look at their IQ score, is between here and here. This is one standard deviation away from the mean. But those aren't the numbers that I'm looking for. If I have 100 minus 70, that equals 30. That's x bar minus x. You could say the absolute value. You could just take the absolute value and make it x minus x bar for both. This would be the absolute value of 130 minus 100, which is also 30. We're 30 away from the mean on both sides. I want the absolute value of the mean minus x. This is 30, and our standard deviation is given right here, is 15. That gives me 2. This is 2 standard deviations from the mean. And if I add 15 more, I'd be 130. If I subtract 15 more, I'd be at 70. 2 standard deviations. How much data is between these 2 numbers? And using the empirical formula, we know it's 95%. This is 95% of all our data lies in that yellow part. That's coming from here. X bar minus 2 standard deviations, X bar plus 2 standard deviations, and we go up here and we can see 95% of all data lies within 2 standard deviations. Have a great day. Bye-bye.